So this question is asking about stationary waves. It doesn't say stationary waves in the question, but the fact that it says first harmonic here means that we know we're talking about a stationary or a standing wave. And the question's saying that what is the phase difference between particle P and particle Q on this stationary wave? Now, the important thing to remember about stationary waves is that between two nodes, and here the fixed ends are acting as the nodes, are points of no displacement, between two nodes every particle is going to be in phase. And conceptually this can be a little bit difficult to think about, so let's have a quick look at a picture. So in this animation you can see we have two waves. They have the same wavelength and they're travelling in opposite directions. One's going left to right, one right to left. As they pass through each other, we get superposition taking place. And so we end up getting this stationary wave that oscillates between having our maximum and our minimum displacements, but those points are all staying at the same place. Our nodes, our points of no displacement, are occurring at the same place, and our antinodes, our points of maximum displacement, are occurring at the same place. Now, if we take a snapshot of this, and I'm just going to draw this out quickly, then let's say here's our stationary wave. And look carefully at the diagram of what's going on. Let's say we take it at the point at which it reaches its maximum displacement, so right about there, and that's what I've snapshotted here. Instantaneously at that point, this is going to be at maximum displacement. But if you look at the stationary wave as it moves, this particle is also at its maximum displacement, and this one's at its maximum displacement. All of the particles in this snapshot are at the greatest possible displacement that they will ever reach from the equilibrium position. That is, they are all at the same point in their cycle. This little particle here will only ever oscillate from here down to here and back up again. And let's say that took 2 seconds. Well, our one in the middle here will oscillate from here down to here and back up again in the same 2 seconds. That point is technically travelling faster, which is why we get the most energy at the antinode here. So the key thing to remember is that between two nodes, the phase difference of any two particles between two nodes is always going to be 0. They're always going to be in phase. And that means that our answer is A. It's also worth noting that if we look at either side of a node, this particle here is just about to start moving down. This particle here is just about to start moving up, but they've got the same size displacement, albeit positive on the top and negative on the bottom, as each other. So either side of a node, they would be in antiphase. They would have a phase difference of pi radians or 180 degrees.